This visualization represents a legacy enterprise pricing platform. The business-critical logic, the core domain, is physically and conceptually buried under peripheral workflows, database access protocols, and mechanical baggage. Modifying a single pricing rule means developers must navigate a labyrinth of unrelated generic subdomains just to find the relevant logic. This friction triggers a predictable response. Teams fall into a refactoring trap, applying localized clean code techniques wherever the code happens to hurt the most on a given day. Scrubbing individual methods and supporting modules provides zero structural benefit to the overall architecture. The complexity of the domain itself remains untouched. We have to prioritize strategic leverage over peripheral cleanliness. This requires a strict methodology called advanced distillation. We regain control by surgically extracting the core domain, allowing it to evolve independently while the surrounding mechanics remain static. Consider a calculation engine where risk rules, represented here as a magenta cluster, are tightly bound to a Monte Carlo simulator, shown in green. A domain model exists to propose business intent. It formulates the rules of the problem. But in this state, that intent is suffocated by the implementation details of how the simulation runs. We resolve this by extracting the simulator into a cohesive mechanism. This is a formalized algorithm designed strictly to solve a computational problem, completely stripped of any domain-specific meaning. By surgically slicing the risk rules away from the simulator, we physically separate the what from the how. We then wrap the simulation engine in an intention-revealing interface. The domain model now connects strictly to this bounding box, entirely ignorant of the complex machinery inside. The core domain is now free to operate in a declarative style. It states facts and delegates all the sticky computational heavy lifting to the framework. Consequently, engineers can optimize or entirely replace the simulation engine without risking the integrity of the business rules. There is a strict boundary to this technique. Do not extract algorithms that constitute the core domain's actual logic. The goal is to remove the mechanical burden, not the business intelligence. Extracting these mechanisms unburdens the core, allowing it to function as a highly expressive language for the business problem. Beyond algorithms, we must address how the system is physically organized. Often, elements of the core domain are scattered across generic packages, buried next to reporting modules or security protocols. This physical scattering fractures developers' mental models. It becomes nearly impossible to see the most important relationships when the code is distributed across unrelated directories. The solution is to build a segregated core. This means refactoring the model to physically relocate all core concepts into a single, dedicated package. This diagram illustrates the structural shift. We move from the scattered implementation boxes at the top, extracting the critical assets down into a single, centralized core package. Notice the arrows within that bottom centralized folder. Dependency lines within the segregated core become short, dense, and highly communicative. The cohesion of the business logic spikes. This maneuver comes with a strict architectural trade-off. External coupling to supporting subdomains might temporarily increase, stretching dependencies across the wider system. That cost is acceptable. The primary objective is clarifying the core domain so that it is easy to work on.
Minimizing peripheral relationships is a secondary concern. However, simply moving files from one folder to another without actually strengthening the underlying domain model accomplishes nothing. It is a meaningless gesture. True physical segregation makes the primary business asset completely visible, ensuring your refactoring effort is concentrated exactly where it delivers the highest return. As a system scales, you often hit a structural wall. Multiple specialized subdomains attempt to communicate directly, creating a dense web of horizontal dependencies. When subdomains interact this heavily, they require massive amounts of cross-referencing. This tangled web completely defeats the value of partitioning them into separate modules in the first place. We break this gridlock by identifying the most foundational concepts shared across the system and factoring them into an abstract core, a shared, higher-level module composed strictly of interfaces. Instead of moving laterally, we'd extract upward. The specialized subdomains remain in their respective layers, while the foundational concepts rise into a central hub. The horizontal lines between the subdomains vanish. All specialized modules now point vertically, adhering to the pure interfaces defined in the hub above them.
This provides a succinct view of the system's main concepts and interactions, completely stripped of any specialized implementation clutter. Executing this requires deep domain understanding. It is an exercise in conceptual modeling, not a mechanical task of simply turning every class into an interface. If you force an abstraction before the foundational interactions of the system are clearly understood, you will produce a rigid and meaningless mess. Built correctly, the abstract core provides a rigorous language for the system's high-level interactions, allowing the specialized modules beneath it to change independently. With the boundaries drawn, we must focus on the code inside the segregated core. Effective distillation extends into the internal logic, requiring the continuous refinement of model boundaries into a deep model. The path to a scalable architecture is sequential. Extract the mechanical algorithms, physically segregate the core, abstract the foundational interactions, and refine the resulting model into crystalline simplicity. Technical resources are finite. Software architects must spend their refactoring budget in the core domain first. Maintaining spotless code in generic subdomains is a secondary concern. Without a distilled core domain, even simple business changes eventually become too expensive to implement. Distillation is the deliberate extraction of your most vital business value, isolating it and protecting it from the inevitable entropy of the surrounding system.